Okay, good morning, everyone. So today we will start to have our lectures in fluid and particle mechanics. And since in our last, just a sec. Okay, since in our last class, I have maybe explained some backgrounds why a chemical engineer or chemical engineering students should study fluid and particle mechanics, and hopefully you can get the grasp of why this course is quite important for your maybe fluid mechanics and particles itself. You might not get the concept again or the lectures again in your future class. Jadi kuliah ini, mekanika fluida ini mungkin tidak akan kalian dapatkan lagi gitu ya di tingkat-tingkat berikutnya, dalam artian in terms of some of the subjects that you will learn in your next semester maybe doesn't require any concept or any correlation with fluid mechanics. Some will be connected, some mostly is not connected. But later, when you are doing your final project, we have plan design, especially. Then you will need to remember again the concept that you get in these lectures. So I hope you can study well in this lecture and you can get the concept, the application. I mean the basic concept and also the basic application why you need to learn about the fluid mechanics. Okay. This is the 5 course learning outcomes. There are 5 outcomes, and we will assess you in the exam to evaluate whether these 5 outcomes is achieved and how much is the achievement. Because now chemical engineering ITB is internationally accredited. Previously, we are accredited by ABET, Accreditation Board of Engineering and Technology, and later maybe we will shift to IAB, another international accreditation. And the accreditation require us to always assess each of the student achievement for all the learning outcomes in each subjects. So we will have 5 learning outcomes that will be spread throughout the modular exam. And I have revised a bit this one. I will upload the revised slide in EduNext and also in MS Teams. You can see from the course outline, this subject is quite dense. The material is quite dense. Jadi kuliah ini memang bebannya cukup padat, materinya cukup padat. You can see that we will cover from the fluid statics and then fluid dynamics, and we will learn about mass and energy balance, but specialized in fluid flow case. And later we will study about the energy supplying devices, pumps, blower, compressor, and also including the flow that we call it compressible flow, because we will have different types of fluids that will show different behavior when we change the pressure or we change the temperature. So we will study about the incompressible flow first. This is simpler, and the equation is simpler, and the concept is simpler, of course. And then we will go to the compressible flow. After that, we will cover about the two-phase flow. Two-phase flow is in these subjects, we will discuss about gas and liquid flow, because in some operation, for example, in oil and gas operation, the fluid is not a single fluid. It will be liquid mixed with gas, and the behavior, how the flow pattern, it's quite different between two-phase flow and single-phase flow. Then afterwards, we will discuss about fluid flow that contains particles, or we call it solids. Maybe from our last discussion, you can get some concept or some example why we need to study the fluid flow containing solid particles. And we will touch a bit about non-Newtonian fluid. This is types of a bit special kind of fluid that have a different behavior in terms of viscosity. And lastly, we will discuss about mixing or pengadukan, because mixing basically is one important operation in any chemical industries, including that we will discuss about the scale up, because you may understand that the purpose of or the difference between chemical engineering with chemistry is we want to bring up the reaction into economically feasible terms, right? Economically feasible scales. It means we need to increase the volume of the product. If we want to increase the volume of the product, of course, we need to increase the volume of the raw materials, and also we need to increase the size of the equipment. And mostly when we increase the size of the equipment, problems about mass transfer, later you will get mass transfer, will be more dominant. The problem about mass transfer will be more dominant if we are dealing with big scale, or the big scale, because you can imagine if you want to conduct reaction in a small volume, you can just have a small beaker glass or small Erlenmeyer, then you just put a magnetic stirrer, or you put stirrer, the device, the small device, then you can make sure that the mixing in the small scale is perfectly happen. But if we want to conduct the same reaction, but the volume is maybe 100 cubic meters, like 10,000 times bigger than the lab scale, you cannot use magnetic stirrer anymore. You need to install what we call agitator or big mixer. But if we are using big agitator, it's not guaranteed that the mixing phenomena is the same as small scale. Some part of the big tank might not be mixed well, and the results, the reaction might not be as good as small scale. So you can imagine that will be most challenge in big scale reaction. Later you will learn about this one more intensively in chemical reaction engineering. Okay, so this is these are the topic and also the subtopic for fluid and particle mechanics. Since we have two lecturers, myself and Pak Anggit, so we decided to divide the subtopic with this arrangement. So I will teach this class until energy balance with friction, including friction in the pipe fittings. And then later Pak Anggit will continue, because Pak Anggit is more is better in teaching you about the pump, blowers, and then compressible flow, and then two-phase flow. Then Pak Anggit will teach you until this part, the fluid flow with solids. And then I will come back again to teach you with the non-Newtonian and also with mixing. Okay, this is the, I think, where is the, yeah, this is the books that you can read to help you to understand this course better. And I suggest you not only for this subjects, but especially for these subjects, because we cover quite a lot of topic. I suggest you to always read the slide before coming to the class. So you can read the slide first, so you can get some grasp of the information that will be discussed in the class. And if you do not, if you have something that you do not understand before the class, you can read the reference. And still, if you do not understand that during the class, you can ask the lecturer. That's why I suggest you not to come to the class with empty head. I mean, do not expect the lectures to always explain in detail from A to Z, because we do not have much time for that. You can see that the hours is quite limited. So I suggest you to read first. Read first, whether it's the slide, and then read the reference. And then after some parts of the subtopic has been teach, I suggest you to try the examples. This course will be dealing with quite a lot of equations. Maybe in the beginning of the lectures, beginning of the subtopics, the equation is simpler, easy to understand, and can be applied to quite a lot of case. But later, we will deal with quite a complex equation. The equation is quite long, a lot of equation involved. Sometimes you cannot use one equation for all the case. So you need to understand what kind of assumption that you need to use before using the equation. That's why I suggest you to read first, understand first by the slide or with the reading the reference book. Okay, we do not ask you to memorize all the equation because we will have the exam. Actually, during the online class, we will do the 3 module exam all with open book. So you may use the textbook, you may use the slide, or you may read your own notes to help you during the exam. But please work independently. You cannot ask your friend, you cannot discuss the question with your friends, or maybe you cannot ask your brothers, sisters, or parents, etc. So you need to do it by yourself. But you are allowed to read all the materials during the exam. But of course, if you do not understand, open book exam will be very daunting, right? You don't know where to find the equation, which slide will be related to the question, something like that. That's why I suggest you to read and understand first, and try to do the example, latihan soal ya. Try to latihan soal as much as you can. Not to memorize the soal, but to enhance your understanding. Ya. Jadi latihan soal bukan untuk ngapalin soal. Oh, kalau soal gini ngerjainnya begini, kalau soal gini ngerjainnya begini. Not completely wrong, but sometimes the assumption is different between one soal and another. That's why when you want to use some equation, you need to understand what is behind that equation. What kind of assumption that you can use? Is the assumption is the same or is it different? Okay. Any question about the course outline, reference, exam? You may directly open your mic and ask, because if you raise hand, maybe I cannot see who's the raise hand. No question?
Sir, I have a question.
Yeah, sure.
Okay, you told us to like review the materials before the class, right?
Yep.
Before the class, are you going to tell which materials we are going to learn, or we have to like review it ourselves?
What do you mean? I mean you can see from this one, right? So the subtopic that will be delivered in each weeks, you may refer to this table.
Okay, sir. Thank you.
But sometimes maybe it's shifted. Sometimes some subtopic is longer than expected, and then some subtopic is shorter than expected. So yeah, it's flexible actually.
Okay, sir.
And maybe if you see the subtopic, some of the topic you already learned maybe in your high school, maybe in your TPB, in your basic physics or basic chemistry. So I will deliver the subtopic maybe in the first, I think, yeah, for fluid properties, that fluid statics, some of the lecture will be delivering in maybe faster pace. But later, when we do we learn the concept, then maybe I will try to slow down the pace. But anyway, if you have some doubt or some question during the class, you can directly ask. No problem.
Okay, thank you very much, sir.
Okay. Anything else from other students?
Excuse me, sir, I want to ask.
Yes.
Out of all the references, like the book, which one you recommend us to read?
All? No. I think number 1 and number 3 quite the same. This 1 and 3 both are covering unit operation. So in terms of preference, maybe I suggest you to read number 1. Giancoplis is, I don't know, for me, it's easier to read and easier to understand. But for the second one is usually, not usually, this is for the like pumps, and then the fluid and solid flow, and then compressible flow. The equation mostly taken from these books. That's why I suggest you to read at least 1 and 2. Not all from page 1 until last page, of course. Just try to download because now I think these 2 ebooks are available, so you can compare the subtopic that will be covered and the chapter in both reference. Okay.
Okay.
Hopefully it answers.
Yeah. Okay.
Yeah. Okay. Any other question? Okay, if you do not have any other question, then maybe I will start. This is still some background that might useful for you, why we need to understand and study about fluid mechanics. So basically, oil and gas company is one of the industry that you might be interested to apply after you graduate, or probably your parents now are working in oil and gas company, whether it's in Indonesia or outside. So basically, when you process the oil, it will start with the drilling the oil, right? And you may understand that oil is available in the underground, or maybe at the sea, right? That we call it offshore. And oil is available in a very unique condition. Sometimes the oil part is a lot, or maybe sometimes it mixes with water, or maybe sometimes it mixes with the solid particle. The characteristic is different between those types of oil. And in order to process the oil, you need to drill, right? You need to drill maybe the depth from the reservoir, the source of the oil with the surface is very, very high. The head of the oil will be very, very high. It will contain some pressure that you will need to overcome when you drill the oil. That's why you need to understand the characteristic of the fluid. Oil is one type of the fluid. Water is also another type of the fluid. Gas, sometimes oil is also mixed with the gas, and that's another type of the fluid. It has certain pressure, what we call it hydrostatic pressure, that you need to understand also when you want to prepare the drilling equipment. You need to calculate the pressure, and then you need to estimate how much is the depth, and with the characteristic of the oil, what kind of equipment you need to prepare. How much is the pressure at the Okay, how much is the pressure over here? And then how long is the depth? Berapa kedalamannya? And then what kind of equipment that you need to prepare in order to have this oil and another component to flow out to the surface. And then you need to estimate how much is the pressure at the surface. What is the composition of the raw materials, oils, and then the particles, and then maybe gas, maybe water. What is the density? What is the viscosity? That's why you need to understand what is density, what is the viscosity. Okay, you need to understand about the concept of the pressure, and then beside equipment, then you need to understand the materials that you need to prepare in order that the flowing oil will not break the structure of the equipment. That's why in other subjects you need to learn construction. I don't know the name of the subject, bahan konstruksi. I don't know the name in English. That's one. Yeah, then that's why you need to study the fluid mechanics. Or another place when you want to apply after you graduate is, of course, a chemical plant. When you go to chemical plant like this one, this part, you always can see that pipeline system or piping system in chemical plants is very complex. You cannot find this only contain one single pipeline and then in the horizontal manner from one end to another end. It will be very complex with a lot of joints, a lot of elbows, a lot of turns, something like that. You may find also valves, tanks, and etc. And to deliver the fluid from one place to another, it's through the piping system. That's why the piping, in order to be able to design the correct piping system in certain chemical plants, you need to understand the fluid mechanics. What will be the properties of the fluid? What will be the pressure at the source, at the tank of the raw materials? What will be the pressure? What will be the length from the raw materials tank, from raw materials tank to the reactor, for example? How long is the pipe? What will be the construction of the pipe? Then, in order to design this piping system, you need to understand some concept of fluid mechanics. Okay, maybe I'll just explain this quickly. So if you have like this one, this is the example in piping system. Then later you will hear the terms like pipes, of course, pipe, and then fitting, elbow, reducer, flange, etc. Okay, actually like this one. So you have, for example, you have 3 tanks. Then you need to connect each of the tank. Of course, you need pipe, right? But when you want to connect, menyambung, to connect the pipe to the tank, how you proceed that? Any idea? Givari. Sorry, I start to ask if you do not open your mic. Are you there?
Yes.
Do you have any idea if you have a tank that
Yes.
you want to connect to another tank with the pipe, what will you do with the tank and the pipe?
What would you do? I'm still not sure. Maybe like, wait, hold on.
Do you just make a hole in the tank and then you weld, you know, right?
I think if you make a hole, there'd be like fluid still coming out of the thing. Cause like maybe something that's to connect the pipe with the tank. Maybe there's something in the middle. I don't know how you call it, but
Yeah, of course. But of course, you need to make a hole in the tank in order
yes.
to join the pipes. But basically, you do not directly weld the tank. Weld mean last, yeah.
Oh.
You do not directly you can directly weld the tank with the pipe, but the problem is sometimes you need some maintenance. Maybe you need to clean the pipe, maybe you need to clean the tank. If you just weld the tank with the pipe, it will be very troublesome. So you need to use what we call flange. I think you will this one. So in this part, you need to connect it with flange. So one types of fittings is flange, and then if you see the figures, you have three tank and you have a pipeline, and maybe the head of each tank or the head of the hole from each tank is not in the same height. Then the tanks, the pipe will have like vertical alignment and then horizontal and then vertical again. That you see, you need to have a joint between the pipe. Sometimes we can use elbow, or maybe you can have a like this. So you have you want to make a branch, so you have T, elbow, T, flange. We call it fitting. There's various types of fittings. Fittings basically is piping accessories. Whether it's to menyambung, to connect the pipe, to branch the pipe, to change the direction of the pipe from maybe vertical to horizontal or vice versa. Let's call it fitting. And sometimes you want to, this is elbow. Sometimes you want to connect bigger diameters of pipe into smaller diameters or vice versa. That's why we use reducer. That's also types of pipe fitting. Yeah, that's why maybe, not maybe, later in the subjects, you will learn about fitting and what will happen in the pipeline, what will happen with the flow in the pipe, fluid flow in the pipeline if you install fitting. Okay. Beside elbow, reducer, T, and flange, we also use valve. Anyone knows the function of valve? Keran. What is the function?
Is it?
Yes.
Maksudnya boleh. Oh, ya udah. I'm just gonna guess. Is it to open and close certain parts of the pipe?
Yes. First, the function is to open or close the flow of the fluid. Maybe we just want to flow the fluid from tank 1 to tank 3, and then we do not want anything comes from tank 2. Then we install valve. Beside that, valve is also used to adjust the flow rate. Some valve is only meant to open and close. Some valves can be used to adjust the flow rate. Okay, so if we adjust the flow rate, it means the velocity of the fluid will be changed. If the velocity is changed, the pressure is also changed. That's why you need to in this lectures, in this subject, you will learn about valves, and some valve can be installed to make sure there will be no we call it backflow or back pressure. For example, we only want the flow. You still remember, right? Fluid will be flowing from higher or lower pressure. Ayo diingat lagi TPB dan SMA-nya. Cairan atau gas itu mengalir dari tekanan yang tinggi atau tekanan yang rendah?
High pressure.
Yeah, it flows from higher pressure to lower pressure. So, for example, we want to flow the liquid from tank 1 to tank 3, for example, and then because the pressure is higher at tank 1 compared to tank 3, but maybe in some condition, the pressure at tank 3 might becomes higher and it will flows back, or we call it back pressure. If we do not want this flow to be happen, then at some point we need to install, we call it check valve. So to make sure that the liquid or maybe the gas doesn't flow in reverse direction because of change in pressure in the endpoint, we install check valve. So it will stop the flow at some part of the piping, some part at the pipeline. Okay, maybe that's some story behind these figures. Later you can read these figures again. And beside pipeline system, pipe installation, maybe at your house. Do you live in the house, right? Do you know where the place where your father placed the pump in your house? Geraldi, are you there?
Yes, sir.
Yeah. Do you remember at your house where is the position of your pump? Do you use pump or PDAM?
I don't know, but like, I think there's a pump in the first floor. I think I don't know.
Pump in the first floor. Okay. In front of your house or behind?
It's in the middle of my house.
In the middle?
Under the stairs, like there's a.
Really? Okay, okay.
Yeah.
But do you know the position of the well, the water well?
I don't know, sir. Sorry.
Okay, mostly if you pay attention in your house, the well or the water reservoir will be under the ground, right? Whether it's in front or at the back or maybe at the bottom of your house, then you install the pump at the surface. Yeah, so we call it a static lift. Yeah, so the pump will suck the water from the well. It means there will be some pressure difference between reservoir, between the base of the well and the surface of the water, because the height of the well normally is around 20 to, like around 20 until maybe 40 meters, right? So the hydrostatic pressure will be different between the well, within water at the base and water at the surface. And then it will be sucked by the pump and it will be delivered to the bathroom, for example. But for some cases, you may have a water torrent, right? Do you have this one? at your house? It's normally at the higher level of your house, maybe near the roof. Anyone have water torrent at their house? You have, Geraldine?
Yeah, I think so, sir. Like it's at the roof. At the top.
Okay, maybe after this class, you need to check where is the position of your pump and your water torrent. And sometimes before delivering to the, if you have water torrent, why it's placed at the near the roof? Anyone can know? Anyone can try to answer. Why water torrent is not normally is not at the level 1 of your house? If you have maybe 5-story house or 6-story house, why it's not at the level 1, but it's always near the roof?
Yeah. So the water will flow naturally, sir.
Water will
It will flow naturally, like from
naturally. Why?
because it's like gravity. It will fall down. You don't
Is
need
it because of the gravity?
No, it's because of the potential energy, I think.
Yes. So you already know about the potential. Yeah, correct. So if you place the water torrent at the higher position, the potential energy will be bigger. So the higher the position, the bigger the potential energy. It means the water contains more energy. So when you have, for example, bathroom in the lower ground, lower grounds mean lower potential energy, right? So the water can flow naturally. But sometimes the energy that contain the potential energy is not enough. So when it naturally flow, the flow in the bathroom is not high. I mean, you may not get the velocity as much as you want. So sometimes people install pump as well to increase the energy. Or if you have water torrent at the house, maybe in the lower level, and you have, for example, you have water torrent at the 2nd or 3rd floor, and you have like in the hotel, perhaps not in the house, maybe you have like 30-40 stories, then you need pump to deliver the water. So the energy, the velocity will be okay. Okay, any question about pump installation? Later we will discuss about the pump and pump installation in the later subtopic. Okay, like this is example of fluid flow with particles. This is we call it fluidization, and basically these figures represents the different behavior of the fluid particles. So the orange one is the fluid particles, and why the solid particles will have different behavior? It is due to the different velocity of the gas flowing through the column. So the right side means increasing gas velocity. You can imagine, right? When the gas velocity is quite low, then the bed is not moving at all. It call it packed bed. But once the gas velocity is increasing, we can expect that some solid particles will move with the gas, but some still remains in this position. The higher the velocity, the movement becomes visible, and at certain gas velocity, the particles will start, not start, the particle will move along with the gas. We call it the fluidization phenomena. And I think I already explained to you, right? Fluidization is one example of the design of the reaction in chemical plant, especially if you have raw materials in gas phase and you have the catalyst in solid phase. So you can conduct the reaction whether it's in a packed bed condition, it means the catalyst in the fixed position, or in fluidized condition. Depends on the reactor. Or maybe later, if you heard about the gasification, gasification is the process of combusting some raw materials, normally in solid form. You combust it. It means you react it with oxygen. You react it with air at a certain composition, certain temperature. Then the operation can be performed in fluidization condition. Okay, this one quite complex, the process. I have put some video about the FCC process. If you're interested, you can watch it in EduNext. It's also one particular process that happens in oil and gas company, normally in the surface facility, to convert the oil or the gas into the composition that we want to produce, like gasoline, like gas oil, or others. Okay, filtration. I think we already discussed about this in our last class. Filtration is either you want to have clear liquid, because some liquid might contain particles or solid. And then either you want to get the solid or you want to get a clear liquid. So you do the filtration. Either you get the filtrate. Filtrate is the liquid one, the clear one, or you get the cake. Cake, or maybe if you later, if you study about membrane, it's called a pentate. Yeah, either you want to get the filtrate or you want to get the cake. So you do the filtration. You separate the solid from the liquid. In a small scale, you just use a funnel or maybe filter cloth or other types of filtration apparatus. But in a higher scale, there are quite a few different types of equipment based on the filtration, based on the characteristic of the solid and the liquid that contained in the raw materials. Okay. Okay, any question about this example? Okay, operation that deals with some operation for dealing with mix between a solid and liquid will be explained later in the later subtopic. Okay, now we go to the fundamental knowledge that you need to understand in order to study the fluid mechanics as a chemical engineer. Okay, maybe some part is already learned by you during the high school or TPB. So basically, we will be dealing with the some dimension and properties. Fluid properties, some fluid properties that important for us to design all the equipment, all the process that we have been discussed before will be discussed in this subtopic. And also later we will see about the dimension. Dimensions mean the units, what will be comprising the units of the properties. Ya, jadi properties, sifat-sifat fluidanya, dimensi itu adalah satuannya apa? Komponen dari satuannya itu terdiri dari komponen apa saja? Okay, basically properties is classified into two general categories. Which one? One is extensive. Extensive properties means the properties of the fluid will be increasing, or it will be depending on the mass or the amount or the volume of the fluid. For example, if you have 1 gram of water with 1 kilogram of water, the volume will be different, right? The mass, of course, will be different. So we call it extensive properties. It will be depending on the size, on the amount. The other one is intensive. Intensive is doesn't depend on the amount, doesn't depend on the size. You can name it, for example, temperature, density. The temperature of 1 gram of water compared to 1 kilogram of water is the same. The density is also the same. So we call it intensive properties. Okay. In this subject, later you will be dealing with lots of units because we will deal with quite numbers of properties. So each properties have their own units. Units is comprised from certain dimension. You still remember, right? Mass, and then temperature, and then time is one of the basic dimension. So for the units and dimensions, we can use one is standard unit, or we call it SI unit, official unit system. So for the mass, it will be kilogram. For the temperature, it will be Kelvin. And for time, it will be second. But sometimes we can use different units. For example, for the mass, we can use gram. For the temperature, we can use Celsius. And then like for the length, the SI unit will be meters, right? But maybe we can use centimeters, or maybe we can use feet. Okay, I hope I won't explain this intensively. I hope you can open again your TPB books, your basic physics books, and learn again how to convert from one units into another units. Okay, maybe one tips, you memorize the standard unit, and then you can memorize the later we call it homogeneity of the units. For example, if we discuss about the pressure will be in Pascal. Pascal will be equals to Newton over square meters, right? And then Newton will be kilogram meters per square second divided by square meters. Yeah, you need to refresh your memory about the unit conversion, because in these subjects, maybe later in the exam, you need to do the conversion. Okay, this is the types of system that normally use. Why we need to know, or we need to be able to do the conversion between each system, because later when you get the data from industry, maybe when you already graduated and you work in the company, the data that you get mostly, I don't know why, you do not get it in the standard unit. Like in the class, maybe from high school, TPB, we always use a standard unit, right? Because it's the most, it's the easiest one to memorize, I think. But later, when you deal with the real case, like company, different companies, some company come from America, from England, from other part of the world, the units that they use is not always in standard unit. Mostly it's not in the standard unit. Like American likes to use a feet, for example, or pound mass. They will have pound force. So starting from now, you need to familiarize yourself with the unit conversion. Okay, and then you need to familiarize again with derivation. Like force, the standard unit is Newton, like I've told you. The primary unit will be equals to kilogram meter over square second. And then like work, energy, the unit will be joule. Joule will be equals to Newton meter. Newton will be equals to this one, etc. So you need to start familiarize, and you need to start to memorize, at least for this table, because like force, energy, power, area, volume, density, etc. We will be dealing with this quantity quite much. Okay, any question? I think it's still okay, right? Just please refresh again your memory about the units, dimension, conversion. And one tips that later you can use during your exam is if you know the units of the parameters, for example, what is the unit of the pressure? What is the unit of the velocity? What is the unit of the force? And then in the exam paper, you are asked about the length of the pipe, maybe, or maybe the energy of the kinetic energy, maybe. Then if you forget the formula, you can try to analyze the units homogeneity. That means the question parameters, if you know the units, then you can correlate it with the data parameters. You can try to mix and match so you can answer the question. It's called the homogeneity aspect of the unit. For example, this is the equation that used when a liquid flowing through the orifice. Orifice is very small hole at the tank, for example. But later we will discuss it in the fluid static subtopic. So basically, when you have tank, then some orifice at the bottom, the tanks that have some orifice at the bottom, that the liquid will flow downwards, right? So the velocity at this orifice, velocity of the fluid coming through the orifice, you can calculate by this equation. This is the volumetric rate. Volumetric rates mean, do you know the units of the volumetric rate? Laju alir volumetric, kira-kira satuannya apa? When you see the rate, it means divided by time, right? Volumetric, it means volume. So the unit will be, in SI unit, will be this one. So this one is this one. A is the area. So this is the orifice area. So square meters. G is gravitational acceleration. So it's this one. And H is the height of the tank. So this will meters. So you can do the analysis of the units, whether the formula is correct or not, by check the homogeneity of the units between the left side and the right side. Okay. And why we have this one? This is what we call correction factor, or we call it a constant factor. Why we have constant factor? Later when we study about the static fluid or the fluid flow, we learn why it has a correction or constant factor. If the ideal condition, the constant will be 1, but since this is the real condition, we get the 0.6. Later we will study about that. But this is the example that you can correlate the formula of the equation, or you can understand the formula by doing the analysis of the unit. Okay. Okay. The other properties, I think it's the it's still a refresher for you. We have mass Mass is the measure of the amount of the substance. What is the unit? What is the unit of mass?
Kilogram.
Yes, the SI unit will be kilogram. And then we will have what we call weight. Yang satu adalah massa, yang satu adalah berat. In Indonesian term, maybe we use it interchangeably. The unit will be kilogram, but actually berat or weight is mass that also affected by the gravity. I means this is the terms that we use to quantify the mass by including the gravity factor. Okay, the gravity, normally we use 10 or later, please use 9.8. The unit will be meter over a square second. But in other calculation, the unit might be changed into feet over square second. So it will be 32.17. Okay, how about force? Okay, if you have weight where it's mass times gravity, what will be the unit? Satuannya apa?
Is it Newton?
Yeah, it should be kilogram meter over square second. This is mass, this is gravity. It will be Newton. Okay, how about force? Force is basically mass times
Acceleration.
acceleration. The unit will be also kilogram meters or square second or Newton as well. So what will be the difference between weight and force? Apa bedanya?
I like to answer.
Okay.
I would say weight is like the force of gravity, and for the force itself. Oh, what was the question again?
Yeah, what is the difference between weight and force? Because the unit is same, right?
Yes. Maybe force is like for the force on like a body, not on Earth.
Sorry, can you repeat again?
I was saying like the weight is like the force of gravity, right? So, and also like for the force itself is like a force like, directly to a body, not like
Okay, you may explain in Indonesian if you want to. Or anyone else wants to try to answer, it's okay. Yeah, actually, because you have the same units, you can say that weight and force is the same. However, there's slightly difference in terms of what kind of acceleration that affected the mass movement. Yeah, you may get the concept right. So weight actually is special type of force. So we can say it as a weight force. So it's a force that influences mass of the body or mass of something that influenced by the gravity acceleration. What is the direction of the gravity acceleration?
Downwards.
Downwards. It's always downwards. Gravity acceleration is always downwards. However, for the mass, the acceleration is more general terms. If the acceleration is gravity acceleration, that it become weight force. The direction of acceleration is not necessarily to be downwards direction. It can go upwards, sidewards, etc. But seeing from the units, you can say both are the same parameters. just difference in the directions and the difference between what kind of acceleration that influence the mass. Okay, you can see that this is the analysis of the homogeneity of the units. Maybe you later other parameters you can find the unit is the same, but how we call the parameters might be different. So, but if the unit is the same, basically they are both are the same in context, but maybe there are difference in situation, condition, or the direction. Okay, later we will also discuss about what we call viscosity. Viscosity has units, of course. Normally we can use 1 centipoise or 1 poise, or the standard unit will be Pascal second. Density, we can use kilogram over cubic meters for the SI unit, but the other unit, you can use gram over cubic meters or pound over cubic feet. Specific gravity is this one. Okay, or pressure. Pressure, I think you're already familiar, right? The SI unit will be Pascal, but sometimes we can use per unit or atmospheric unit. Okay, that's why you need to familiarize with the these units. How much is the density of water? If you use water, right? If you use the value of 1, the unit will be or you can say, how much is the density of the water? But please mention the number and the unit. Karunia. Okay, Gusti. Dana, right?
Yes. Is it
Okay.
1 kilogram per meter cube?
1 kilogram per cubic
Meter
meters?
cube. Yes.
Anyone agree this one? Water.
Is it 1,000?
Yeah, if you use kilogram over cubic meters, the value will be 1,000.
Yes.
If you use the value 1, it will be kilogram per liter, right?
Oh yeah, sorry.
Yeah, that's why you need to start to have the sense of the units. This is roughly, of course, depends on the what will be contained in the water. But roughly, if we want to estimate the density of the water, is around 1 kilogram per liter, or 1,000 kilogram per cubic meters. But for air, it's around 1 kilogram per cubic meters. Okay. Okay, this one is basically it's just a conversion. I think during your basic physics, you already learned about the concept of gravity conversion factor, or GC. This is the, I don't know, the reason behind this number, but this comes from British units, where they are stating the unit of the F sometimes in this one, pound force. They have pound force, they have pound mass, and how to convert pound force between pound mass is by using this one. Why we have a lot of conversion, why we do not have just one unit that applied throughout the world? I don't know why also. Maybe to make life more interesting, perhaps. Okay, any question about the conversion?
Sir,
Yes.
I want to ask. Before it was said that the common units, there is specific gravity.
Okay, later we will discuss about it.
Oh, okay.
Is that the first time you heard about that term?
Yes, sir. That's why I want to ask.
Okay. Later, if I forget to explain about it, please remind me again. Okay. First, we call it, we will discuss about each of the important parameters in details, but even though in details, I won't explain it very, very long time. First is density. Density is one most important parameters that we use in fluid mechanic calculation. A lot of formula, a lot of equation that will deals with the density of the fluid. By the units, you can understand, right? Density is the mass that contains in a certain volume of fluid. So in one volume of fluid, for example, this should be this one, right? 1 cubic meters. Oh, sorry. This is the sorry. It's actually it's correct. This is not the unit. This is the dimension. So mass is terms with big M, and volume, since it's cubic of the length, so cubic of L. So this is the dimension. It's mass over volume. And I think you already study that the mass that contained in a certain volume depends on each molecule mass and the number of the molecule occupying the unit of the volume. It means the density of certain fluids will be depending on the condition. By condition, it means pressure and temperature. So the same fluid, because density is intensive parameters. It doesn't depend on the amount. It doesn't depend on the size. So the same fluid should have the same density, whether it's 1 kilogram or 1 ton or maybe 1 gram, the density should be the same. But the density may change if they have different pressure or condition. For example, we are using, sometimes the density is stated at standard condition. It means at 0 Celsius and 1 atm. Okay, the unit is kilogram over cubic meters in standard unit. At I think it's 1 atm and 20 degrees C. So water is around 1000, and ethanol is around 800 kilogram over cubic meters. Okay, density we already studied. Sometimes we use density not in density term, but we use it as a specific volume. Specific volume is the reverse term of the density. So if the density is mass over volume, the specific volume is volume over mass. So this is how much the mass in each volume. This is how much the volume in each the mass. Yeah, you can get the concept, right? Ya, jadi specific volume itu kebalikannya. Kalau densitas itu adalah jumlah massa per satuan volume, kalau specific volume adalah jumlah volume per satuan massa. Why we need to use this specific volume? Anyone knows? Why we complicate our life by mentioning density in other units, in reverse unit? Basically, it's also density, but just stated in reversed unit. Anyone know? Okay, I'll start to ask. Yasmin, are you there?
Yes, sir.
Okay, can you guess why people complicate their life, or why we need to state the volume, the density of certain fluid in parameters of specific volume? Why not always in density?
Maybe because there's a specific property for the volume over mass. I'm not entirely sure.
Okay. Any other student that want to guess? During your TPB, you have learned about the conservation law, right? Conservation law. Hukum kekekalan. Have you heard about this one? What kind of conservation law that you know?
Mechanical energy.
Energy. The other one, the simpler one. Selain hukum kekekalan energi, ada hukum kekekalan apa?
The mass.
The mass conservation law. So, since the name is mass conservation law, which one is always conserved, mass or volume? Which one is always constant? If some fluid undergo different condition, like the change in the pressure, change in the temperature, that the parameter that will always constant will be mass, right? Jadi kalau ada fluida, tekanannya berubah, temperaturnya berubah, yang akan berubah, yang tidak akan berubah, yang akan tetap adalah masanya. The mass will be conserved. Whether it's in 1 atm 0 degrees C or in 100 atm 100 degrees C, the mass of the substance, the fluid, will be the same. Masanya akan tetap. How about the volume? It will be changed. If you increase the pressure, the volume of the substance will be decreased. Generally, if you increase the temperature, the volume of the substance will be increased. Ya, jadi kalau volume, kalau tekanan dinaikkan, volume akan turun. Kalau temperatur dinaikkan, volume akan naik. Generally. So if the fluid undergo this change in pressure or temperature, the density will be different. So the denominator, penyebut apa sih? Denominator, what is the English term for penyebut? Anyone knows?
Numerator, sir?
The bottom one?
Yes, denominator.
Denominator, right? So in density, the denominator will be different. But in specific volume, the denominator will be the same. So to basically, we deal with specific volumes to mention the density for the fluid that undergo a very change in volume when the pressure and the temperature is different. Ya, jadi spesifik volume ini biasanya kita akan gunakan kalau kita bekerja dengan fluida yang volumenya akan sangat terpengaruh dengan tekanan dan temperatur. What is the fluids? Normally it's the gas. Liquid is relatively constant when they undergo different pressure or temperature. So for liquid, we can assume the density is always constant. Because volume is always constant and mass is basically constant, right? But when we are dealing with the gas, later we call it compressible fluid, it's easier to put the parameters that always change as the numerator, sebagai pembilang. Okay. Yeah, to answer the question from the student previously, density sometimes is referred as specific gravity. So specific gravity is basically density of the of the fluid, compare or divide it by the reference fluid. So if you have liquid fluid, cairan, so the reference will be the water. If you have gas fluid, gas, the reference will be air, udara. Of course, the calculation of specific gravity is normally will be done at the same condition, especially for the gas. It always done in the same pressure and temperature, and then you just divide it with the gas density divided by air density at the same pressure and temperature. Same with the liquid. The density of the liquid, you divide it by the density of the water at, this is how 277 Kelvin equals how much in Celsius? 277 Kelvin itu berapa Celsius? Ayo. Masa lupa?
Is it 4 Celsius?
Okay, no, please, yeah, this is correct, 4 degrees C. Why we use 4 degrees C for liquid, for water? What happened with water at 4 degrees C? Anyone can still remember?
Is it like the magic state, sir, between like liquid and ice? I forgot.
You can speak louder, please.
Sorry. It's like the state where it's nearly at liquid and ice or something.
Okay, but still in the liquid, right? But what is the special case with water in liquid state at 4 degrees C? Okay, sorry if I cannot draw properly. Zero degrees C, which is ice, 4 degrees C.
Oh, I think when it's freezing, sir, like the top layer is becoming to start freeze, but the bottom layer is still liquid. Is it
not that one?
Not the one.
Anyone else can still remember? What is the specific properties of water? All in still, it's still all in liquid state, but what will change with water? Especially at 4 degrees C, it will have lowest
density, yes, sir.
Lowest volume.
Okay.
So lowest volume means highest density. At 4 degrees C, the water have the lowest volume. I think I don't know whether you still learn about this. We call it water anomaly. So when you cool down the water, the volume, of course, it's not like significantly reduced because water is compressible. But if you incompressible, that means if you decrease the temperature, the volume of the water will be slightly decreased until reach 4 degrees C. If you further cool down the water, the volume is increased again. So that's some specific behavior of the water. That's why in some calculation, the specific gravity is done by calculating at 4 degrees C. Okay, to make things more complicated or more interesting, the American Petroleum Institute, yeah, normally using for hydrocarbon, the specific gravity of liquid, yeah, generally it's liquid, and specifically it's hydrocarbon. The unit of the density is called API. It stands for American Petroleum Institute. How to convert? Then you need to calculate the specific gravity of the substance at 600 Fahrenheit and 1 atm. Of course, you need to state the temperature and pressure. So the temperature is 600 Fahrenheit, the pressure is 1 atm. It means you need to compare it with either, if the gas, you compare it with air. If the liquid hydrocarbon, you compare it with water. Okay, you compare with air or water in this condition, you get the specific gravity value. Then you do this calculation. 1 for 1.5 divided by specific gravity minus 131.5. You get, for example, for the water, the specific gravity will be 10, and for crude oil, the API will be 10, and for crude oil, the API will be 35. So later, if you can get the data of the density from, we call it handbook. Some handbook may write the density value as API value. So don't be too shocked if you read the density in terms of API. It means you need to do this calculation. Okay, until this part. Okay, you can get the value of specific gravity from the table, maybe from the textbook or maybe from the handbook, but please pay attention what is the reference. It means like this one, the specific gravity at 20 degrees C and 1 atm. It means divided by water if the liquid, or divided by air for the gas at 20 C and 1 atm. Unless stated otherwise. For example, this ice at 0 degrees C, this one. It means if the value of specific gravity is higher than 1, the density is higher than water. If lower than 1, it means lower than water. Okay, to check the, later you will have MPA, metode pengukuran dan analisis. I don't know the name of the subject in English. Later in semester 4, you will have that subject, and that subject will contain the experiment. And one experiment is to get the value of the density of the water or maybe other liquid by using device called pycnometer. I have uploaded a video about how to use the pycnometer in the Edonex. You can watch it by yourself later. Okay, you have thermodynamics, right? Subjects, thermodynamic subjects in this semester. I think you have, right? So previously I have mentioned that certain fluid, the density of certain fluid will be greatly affected by the pressure and the temperature. We call it compressible fluid. While other fluid, this is mainly gas. Gas is mainly compressible, while liquid is incompressible. It means it also affected, but not greatly affected by the change of the pressure and the temperature. Then how to correlate density with pressure and temperature for the compressible fluid? We are using the equation of state. Have you learned about the equation of state in thermodynamic class? Not yet? Cherry?
Yes, sir.
Have you studied about equation of state in thermodynamic class?
Not yet, I think.
Okay, the simplest type of equation state is the ideal gas. I think you already know about the ideal gas, but ideal gas is only happen at certain condition. For example, the pressure is very, very low, or the temperature is very, very high. It means the interaction between the molecule of the gas is very, very low. There is no interaction between each molecule. So we can use ideal gas approach, ideal gas equation. From the ideal gas, you can get this equation, right? Oops. Okay, this one is the ideal gas equation. Pressure times volume equals moles times gas constant times temperature. Then moles equals this one. Mass divided by molecular weight of the substance. Then this one is this one, right? So mass over volume is density. So you can change into this one. Then you can have this correlation for density and this correlation for specific volume. That's for the ideal gas. How about the non-ideal gas? How about the real gas? You can use other equation of state. For example, Redlich and Kwong. And then other equation of state, you will learn in details in thermodynamic class. When we can use Redlich Kwong, when we can use I forgot the name of other equation of state. Yeah, there are quite numbers of equation state. Each equation state will have each of assumption. That's why you cannot directly use one formula for all. For example, you cannot use ideal gas as the equations of state for every condition. It's only applied if the gas is ideal. If the pressure is very, very low, if the temperature is very, very high, then you can use the ideal gas approach. But for real gas, you can choose other equation of state. Depend on the equation. Depend on the condition, depends on the assumption. Okay, gas constant R. I think you already remember the value. Normally we use 8.314. If you use 8.314, the unit will be in SI unit. Sometimes it's joule over Kelvin over mole, or sometimes joule, Kelvin, gram mole. Gram mole doesn't mean mass divide times mole, but it's same with mole. So don't be confused. Ya, kadang-kadang satuannya itu joule per mole Kelvin, kadang joule per gram mole Kelvin. Gram mole ini sebetulnya mole, bukan gram dikali mole. Hati-hati ya, sama ini maksudnya. Jadi angkanya tetap 8,314. Kalau 8,314 joule per mole Kelvin atau Kelvin mole. If you are using another units, for example, the press you are using ATM or you are using Celsius or other units, then you need to convert it into another numbers. Okay, any question until this point? Okay, then I will continue. Okay, please remember again that fluids that categorize the phase of the fluid is liquid and gas. And then in the application, we will encounter not only single phase flow. Single phase mean whether it's all in liquid or all in gas, but in the application, we can have mix between gas and liquid. We call it multi-phase flow. Later, we also have liquid, gas, solid, or also gas with solid. That's why some of these phenomena we will study in this lecture. And then compressibility. I think you already get the concept, right? Fluid is called compressible if it has sensitive or significantly changed when the temperature or pressure is changed. It means the sensitive change of density. While for the incompressible, it's less sensitive change in density. Okay, also please remember again the general characteristic of gas and liquid characteristic, like density. Gas is normally having low density, low viscosity, the molecule is loose, and then the molecules is freely easy to move to any direction. We call it ideal gas if there is no attractive force between the molecules. Then real gas, then it means there's some attractive force between the molecules. And later, the density, the viscosity is significantly changed with temperature. So the velocity will also change, affected by temperature as well. Okay. I think I have mentioned, right? At which temperature that the density water reach maximum, it is at 4 degrees Celsius. And then why I think you can search in the YouTube why ice is water, right? Ice is water, but it become solid. Yeah, it's the freezing ice. Normally, solid will have higher density compared to liquid. Ya, padatan solid itu biasanya densitasnya lebih besar daripada cairan. That's why anything solid that you put into the water, it will sink because the density is higher. But for the ice, the case is floating. Then you can try to search in the YouTube why is the phenomenon is like that. Okay, the comparison is the liquid. It has higher density, higher viscosity. The molecule is tight. It means the jarak, the distance between each molecule is closer than the gas. Later we will see that the distance between molecules will be influencing the viscosity. The molecules can still move freely, but not as free as the gas molecule because of the attractive force. And if you apply some temperature, you increase the temperature, some of the liquid will be evaporating. I think that's the characteristic of the gas and liquid you already understand, but you need to remember again. Okay, now we learn about the viscosity. Viscosity, if you heard the viscosity, what comes into your mind? Viscositas. Alika, Zahra.
Yes, sir.
Yeah. If you heard terms of, is it the first time you heard terms viscosity? No, right?
No.
Okay. When you heard terms of viscosity, what comes into your mind?
It's like the resistance of fluids to flow, I think.
Wow. Okay. That's the chemical engineering student that answer. For for general people, when they heard viscosity, what comes into your mind? Viscositas.
Probably.
Before reading this one, if you ask maybe your brother, your little sister, little brother, or maybe you ask your parents, if your parents is not a chemical engineering graduate, of course, what will be their answer when you ask what is viscosity? Apa itu viskositas? Biasanya jawabannya apa?
I don't know. I've never asked my siblings that question.
Okay, Joshua.
Hello, sir.
Yeah. What comes into your mind before reading this one, of course, when you heard the terms of viscosity? Biasanya viskositas itu identik dengan
biscuit maybe. Biscuit.
Sorry, biscuit.
Yes.
Why?
Because I don't know. I've heard of biscuit name Visco.
Oh, that's a brand, you mean? No, not that one. Okay, how about Raha?
Hello, sir.
Yeah.
For me, I think it is thickness of liquid. I think
The thickness
like,
of the liquid. Yeah. Or in Indonesian, when when people heard about viscositas, biasanya related ke kekentalan, betul ya?
Yeah.
How much is the thickness? How much is the viscous of the liquid? Actually, viscosity is not only for liquid; it's also applied for the gas. Higher viscosity means makin kental, gitu ya. Kalau Anda mendengar kalau ada yang pakai motor atau mobil, at certain kilometers, at certain time, you need to change the engine oil, right? Sometimes the engine oil are written 0 to 20, 0 to 10, 20 to 30 W, 30 to 70 W. Have you ever read that numbers at the packaging of the engine oil? Or no? Okay, that's actually the measurement of that's the number of the viscosity. Yeah, so viscosity it's not completely wrong to say that viscosity is the thickness of the fluid, but if we are dealing with the liquid, maybe it's correct. The higher the viscosity, normally it's more viscous, it's more kental, it's more thick. But if we're dealing with the gas, it's difficult to say which one the gas is thick because all is in gas form. So in chemical engineering term, basically the viscosity is parameters to define how much the fluid can resist the force. Do you know shear force?
Is it the maximum, sir?
Maximum? No.
Like, until something change? Oh no, I'm wrong.
Yeah. Okay. Actually, if you have fluid like this, and the fluid is in a static condition, and you apply force, searah means what? Tangential to the surface. Yeah, like this one. So it means you apply force, right? Force that the direction of the force is like this, the same tangential to the, not normal. You will have normal force, like this one is the fluid, this one is the fluid, this one normal force, this is tangential force, right? If you apply tangential force to the fluid, it causes you apply shear force, gaya geser. So force that the direction is tangential to the fluid surface is called shear force. So if fluid experience shear force, it will give resistance. Certain fluids will give higher resistance compared to others. Okay, the value or the measure of this resistance called viscosity. So basically, it's not wrong that viscous fluid, yeah, the fluid that have higher viscosity, higher thickness, will resist more to the shear force. Okay, why the fluid, whether it's gas or liquid, give the resistance? Kenapa gas dan cairan itu bisa memberikan perlawanan kalau dikasih shear force? Anyone know, or anyone can imagine why?
The intermolecular bonds, sir.
Okay. Intermolecular bonds. Do what?
So they cause the layers of the molecules in the liquid to attract to each other.
Okay, yeah, that's correct, right? You can imagine layer of fluid contains molecules of the fluid, right? So the molecules will have a bond with each other. And then we call it intermolecular bonds. And then when we give shear force, for example, at the surface of the surface, there will be some friction, right, between the molecules. The intermolecular bonds basically will make the fluid to resist that force because it has friction, and it's like when the direction is at the right position, yeah. So the top layer of the molecule will move to the right position, but the second layer, it will have to pull it back to the left direction, right? Like that. That's why the fluid will give some resistance when they experience a shear force. So by I hope you can understand the visualization. It's like that. So by imagining that phenomena, liquid will have more resistance because the distance between the molecules is closer. The interactive force is higher, and actually for the liquid, beside intermolecular force, the cohesiveness force, like because they have same structure, right, between molecules, the cohesive force is also high. That's why for liquid, the viscosity is higher. What happens if the temperature is increased? Basically, when you increase the temperature, both for gas and the liquid, the interactive force will be increased. Yeah, because when you increase the molecule, when you increase the temperature, the energy, the moving energy, or the collision energy will be higher, right? It means the intermolecular force becomes higher. What happens if the intermolecular force becomes higher? The friction will be higher, the collision increase, the friction will be higher. Supposedly, the viscosity will be higher as well. That happened with gas. So for the gas, if you increase the temperature, the viscosity will be increasing. It becomes higher. However, in liquid, since liquid experience two interaction, right? Intermolecular force and also the cohesiveness force. When you increase the temperature, of course, the friction is also higher. The intermolecular force is also higher, but the cohesive force become lower because the distance between the molecule becomes increased, right? So it reduces the cohesiveness force, and the impact will be reducing the resistance to shear force. That's why for liquid, if you increase the temperature, the viscosity will be lower. So that's what happened with gas and liquid. Jadi kalau gas itu hanya dipengaruhi oleh intermolecular force-nya saja. Kalau itu temperaturnya dinaikkan, maka intermolecular force-nya akan naik, sehingga viskositasnya naik. Tapi kalau liquid, ketika dipanaskan, temperaturnya dinaikkan, intermolecular force-nya itu naik, tapi cohesiveness antar molekulnya itu turun, sehingga viskositasnya turun. The effect of lowering the cohesiveness brings more significant effect on the viscosity. Okay, any questions so far? Okay, if there is no question, then since it's already almost 12 o'clock, maybe for today's class, I will stop right here, and then we will continue next week. Thank you and good afternoon.